Hi guys, welcome to PCMINR.com and you're watching this video on electronic configuration of atoms of an element by Sonal Gupta. So let's start with electronic configuration. Now, electronic configuration or the electron arrangement, I would say, is just a way or a manner in which electrons are arranged in an atom, and that arrangement of all the electrons in different shells is just based on a simple principle, and that is that different shells can hold different maximum number of electrons. It means that you cannot just put any number of electrons into any shell, because as you know that an atom has a nucleus in the center and the electrons, they revolve in their orbits, in the specific orbits, and it's not just that any number is sitting in any orbit. They occupy that a particular shell based on the principle, and electrons, they start occupying shells from the innermost one. So first of all, the innermost shell is filled. Once that shell is filled, then they begin to occupy the next shell. So only when a shell becomes full according to the principle, like based on how many electrons can be placed in that, then they move to the next shell. So let's see how many electrons can be allowed in a particular shell. So the number of electrons that occupy specific shell is given by or calculated from 2n square. So based on this 2n square, you can calculate how many electrons will be there in that shell, where n is actually the number of the shell we are talking about, like is it the first shell or the second or third and so on. So that means if you want to check in the first shell what will be the maximum number of electrons, it will be 2 times, you put the value of n as 1, so 2 times 1 square, which means it's 2. In the second shell, the number of electrons is going to be 2 times 2 square, so that's 4 times 8. 4 times 2, that's 8. And in the third shell, the number of electrons is going to be 2 times 3 square. So n is 3 for the third shell. So you get 18 electrons. So this way we can go on calculating the number of electrons present in a particular shell by just substituting the value of n in this formula 2n square. So let's check how we can arrange the electrons in an atom. So let's take the example of sodium. Now this electronic configuration is actually predicted from the atomic number. Now we know that atomic number is just indicating the number of electrons in a particular atom, and here we have just taken the example of sodium. Its atomic number is 11. That means that sodium atom has 11 protons and 11 electrons. So let's see how these 11 electrons can be placed in a sodium atom. So in the first shell, we generally call it as K shell, the number of electrons would be 2. Then in the second shell, that's L shell, the number of electrons is going to be 8. So 2 and 8, 10 are gone. Just 1 electron is left, and that will go to the third shell, which we call as M shell. So it's 1 in the third shell. So you cannot put that 9th electron in this L shell because it can accommodate only a maximum of 8 electrons. So this electron arrangement will be written as 2, 8, 1. So we write as 2, 8, 1. Similarly for magnesium, its atomic number is 12. So you'll have 2, 8, 2. Right? And this electron arrangement, you can also represent it as an electron dot diagram. So let's see how you represent it in a diagram. Now in the middle, we have just shown the nucleus. Now the first 2 electrons, they go to the first shell, right? This is your first shell. Then in the second shell, you have 8 electrons. So it's shown with these red dots. So these are 8 electrons, that's the second shell, and the third single electron, it lies in the third shell, that's the last one in the outermost shell. So an easy way to remember is that number of circles in a dot diagram are going to be equal to the period number. So if it's the first period, element of the first period, it will have only 1 shell. If you go to the second period, it will have 2 shells, and so on. As the number of period increases, you will have that number of shells. So for the 7th period, you're going to have 7 shells, and the total number of electrons including of all the shells is going to be equal to your atomic number, which will be we can say arranged in the shells based on that number 2n square. So let's just quickly look at the electronic configurations of the first 20 elements. So electron for hydrogen, it's just 1. Helium has 2, so 2 goes in the first shell. Now lithium has 3, so it goes 2 in the first and 1 in the third shell. So then beryllium is 2, 2, and so on. You go up to neon, whose atomic number is 10. So you will have the configuration as 2, 8. Now from sodium onwards, that 11, 12, so on, you have 1, 2, 3 electrons. They go on adding to the last shell. So it's 281, 282, and so on up to 288. And for the potassium and calcium, it's going to be 2881. I know there might be a little confusion for you that why isn't it 9 here, because it can accommodate 18 electrons, but there's just an energy rule here that these shells, the shells in which the electrons are going, they further have some subshells. Now out of these subshells, the first subshell of the fourth shell, right, the first subshell of the fourth main shell has lower energy. It has lower energy than your third shell's later subshells, or third shell's last subshell. So that's why your 2 electrons will first go in the last shell. So you have the configuration as 2881 and 2882. So this will go only up to calcium, but on the 21st element, now again the third shell will start filling up, right? So this way how you can find out the electronic configuration, and it's really important for you to remember that about the first 20 elements. So that is about electronic configuration. In the next video, we'll bring you the concept of valency. Keep watching and follow us on Instagram and Facebook at PCMINR.com. Thank you.